Good morning, everybody. Very warm welcome to all of you. I'm Wenhui from the Singapore Environment Institute, or SEI in short. SEI is the Training and Knowledge Division of the National Environment Agency. Thank you for attending today's professional sharing series on the topic of satellite-based monitoring of water quality and water depth. This is jointly organized by SEI and the Singapore Workforce Development Agency, WTA. Since 2004, SEI has been staging the professional sharing series, or we call it PSS in short. We've hosted more than 50 eminent academics, policy leaders, and industry experts. I've seen noticed familiar faces in the crowd, so some of you are familiar with this. This is one of our knowledge sharing platforms where we seek to promote the dynamic exchange of environmental knowledge and also enhance the professional capacity of NEA staff, industry professionals, public sector, businesses, and academics. Given Singapore's limited water resources, it is actually critical that water pollution and quality are carefully monitored and regulated. In March this year, NEA deployed a network of buoys with special sensors to continuously monitor ocean water quality for oil and chemical spills as part of its 2-year Project Neptune. Not just confined to Singapore, clean water is actually a scarce resource in many cities worldwide, be it drinking water or water bodies used for recreation purposes. The question would be, how do we actually continuously monitor water quality such that we can do timely analysis and make informed decisions? Today, we have invited Dr. Thomas Heege to share with us how remotely sensed satellite data and spatial analysis could offer the possibility to monitor the environment and its changes on various spatial and temporal scales. Thomas is the Managing Director of UMAP Asia Pacific. He established UMAP market leadership in services on aquatic systems using multi-spectral satellite data. Since 2006, UMAP has successfully applied satellite-based water quality monitoring for government and commercial clients across the world, including World Bank, European Union, European Space Agency, various national river and water agencies across the regions. In the spirit of PSS, which is promoting a dynamic exchange of environmental knowledge, I hope that you will take the opportunity to actually talk and discuss with him during Q&A later on. Without further ado, let's put hands together to welcome Thomas.
Yes, well, thank you very much for coming and also for this interest in this topic. And well, please, I don't know how it is used here in your house here, but please directly interact with me also if you like to go to further details or have questions. You can do it now. We have also time after. I think the presentation will take about 30 to 40 minutes. And well, thank you for this nice introduction. I'm heading the company EOMAP in Germany, so it's the mother house, not in Asia Pacific. That's my colleague Abel Mittal, who's the managing director here of our spin-off here in Singapore. He's also heading SkyMap Global, a geospatial solution provider. So we do this in very strong collaboration. We see, of course, that here in this region there is a significant demand on water quality and water quality monitoring. So I just introduce shortly what our company is doing. So what are the key capabilities? It's about satellite-based aquatic monitoring. So we do water quality, turbidity monitoring, water depth mapping, bathymetry mapping, and seafloor mapping. That's the key issues we do. Also oil monitoring and sea state, but these are the key elements that we are doing. Indeed focused much on water quality and bathymetry. And we have on the other side, of course, a lot of different applications that can be served with these kind of services, and that can take it up. So we are working for the oil and gas industry in different countries, dredging monitoring, offshore and impact construction, and waterways, so biodiversity baselines. So there's a lot. So we are established as spin-off of the German Aerospace Center in 2006, and now 1-2 months ago here in Singapore. We have at the moment set up a reseller web network and work for various clients worldwide. I will talk about the technology so that you also will understand what is the base of what we are doing. then go to different applications so that you can have a look at where it can be applied, these different things. And of course, the summary I would like, of course, to discuss, because usually I like it. There's a little bit of technology behind it. It's good to understand what's really the base and what also are the physical limits if you want to introduce this to your questions. So what we are doing is here water color monitoring. So if you look with your eyes to the color, you will also directly see there's a deep blue water, but there's not much sediments and maybe also not much organic absorbers. But if the water is very green, you will indicate, yes, there may be a lot of phytoplankton, but it could be green or yellow, then that may be just organic components dissolved. And if it's very bright, sediments, bright and yellow sediments, organic loaded. So that's already what we do as we have learned it, and that's more or less the same as we do it from satellite. Also, you see sometimes already with your eye, if you are standing on the shore, line from the color, okay, it is not very shallow here. So there's a little bit more information. So water itself also has a specific spectral absorptions. So if you look to the spectral absorption properties of water, you see the blue line here. So this blue line here is the absorption of water. So you see an increasing absorption to the red and infrared region. It increases even further here. That means in the further infrared, water is essentially black. That is also very important for us because we have to discriminate later for the atmosphere. And then we see chlorophyll here absorbed in blue and red. That means the remaining light is the green one that we see. And then here the organic components of yellow substance, of dissolved organic components, and of tryptophan, so of particulate organic components are very similar shapes here. So that's what we do if we do water quality monitoring. We do go back to these physical scattering and absorption properties in the water. That's what we concretely retrieve. And if you want to understand what is this value that we derive, then these are finally these scattering and absorption values. These are then again related to, for example, chlorophyll A, or to turbidity, or then again over turbidity to suspended solids. So water quality measures are then those I already mentioned. So turbidity can be related again to secondary suspended matter. Or total organic absorption is finally the organic absorption that we see. So some satellite sensors have not so many spectral bands, but we can still derive the absorption spectra in 2-3 bands, but that's not enough to derive chlorophyll. But it's still organic absorption. So chlorophyll and dissolved organic matter, so you see here sign is then we need specific beta sensors to do this. And then of course there's a lot of more interest to generate aggregated products, or products that are related then with these measures. Maybe a short example later. Then we do other stuff, so water depth monitoring, cyclo on macrophytes. I will explain this also, and I think that's where I focus here in the talk. So on the instrument side, we have a lot of different satellites in space already, and the good thing is that if they are physically radiometrically stable, so they measure light intensities, then we can use them all with a harmonized generic processing system. That's what we do. So that means all the derived values later of in water scattering and absorption are harmonized and uniform. That means you can compare satellite of A with satellite B in Vietnam with measures in Europe and in Australia, and also here in Singapore. So here are just a few. Is my voice loud enough, or should I speak like that?